in this video we're going to use quadratics to help us solve a problem that a farmer faces. A farmer has 800 meters of fencing and it's going to be used to construct 8 rectangular animal pens as shown. Alright, so we have 8 pens there, as you can see. They have X meters and we've got Y meters. Okay, so all of these here, they're all the same length, obviously, because we're dealing with rectangles. It's quite important that you read the questions. It says rectangles, which means the length and the widths aren't the same thing. They're different. Alright, now our first part is we have to show that Y equals 800 take 12x over 10. We have to show that. That's our first problem. Now, the 800 is how much fencing he has. The farmer has. He has 800 meters of fencing. So that means all of this has to add up to 800 meters. So if you look closely, you'll see that there are 12 x's. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 x's plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10y. And they have to add up to 800. Now with a little bit of rearranging, we'll get 10y equals 800 Let's get that right. 800 take 12x. Therefore, y equals 800 take 12x over 10. And we just showed that. Now, what we're going to do is we're going to find the area of each pen. So if we have a look over here, area is equal to length times width. That's the area of a rectangle. In this case, it's going to be x times y. We know what y is, so x equals 800 take 12x over 10, which equals 800 x take 12x squared over 10, which is actually 80x take 6 over 5x squared. And as you'll see, that nice and neatly turns into a quadratic. Maybe not neatly, but we've got a quadratic. If it helps, we'll rearrange that to put in a form that you might be used to. 6 over 5x squared plus 80x. Now, it doesn't look like an x squared, does it? X squared plus 80x. Now, we have to find... we found the area. That's what the area is. So now we need to find the dimensions of each pen to get a maximum area. So what we need to do is we need to actually find the maximum of the graph. Now maximum is equal to negative b over 2a. And when we talk about negative b over 2a, we're talking about when we talk about quadratic. A x squared plus bx plus c. That's what we're talking about. And as you can see, it's going to be a maximum because we've got a negative quadratic. So our graph is going to look like this if we were to graph it, and we would have a maximum. And that's what we're looking for. And the way we find it is negative b over 2a, which equals negative b, so it's negative 80 on 2 times negative 6 over 5. And we have to solve that. We have to figure that out. Well, we've got a negative and a negative. I'm just going to move this up again so I can see and work with it. Don't forget you can pause and rewind and go back if you need to. So we've got negative 80, so that's going to equal, this is a positive here, because it's a negative and negative, it's a positive, so that equals 80 over 12 divided by 5, which equals 80 times 5 over 12, because it's 80 divided by 12 times 5. So when we're dividing by a fraction, we flip our multiply, equals 400 over 12, which equals 33.33. So that's what x equals. Now, if we go back to what we had, and we saw that, if we go back, you remember, y equals, we had to show that y equaled 800, take 12x over 10. If we substitute x into that, y equals 800, take 12 times 33.33 divided by 10, we get a value of y equaling 40 meters. Now these are in meters, obviously. So that means the dimensions will be 40 by 33.33, which means the maximum area, the area of each pen, is going to be 40 times 33.33, which equals 1,333.33 meters squared. Don't forget those dimensions are in meters. You can't forget your units like I just did, otherwise you will lose marks in tests or exams. So make sure when you look at the question, this is going to go back over everything you've ever learned in mathematics. Area, perimeter, now quadratics as well. It's going to go through there, so we're going to have to work on that. Rearranging algebra, just following it through step by step.